This is Unit 7, Physical Behavior of Matter, Lesson 6, Gas Laws. How are volume, temperature, pressure, and the number of molecules related in gases? The objectives of this lesson: I can determine the number of particles of a substance using Avogadro's law, and I can determine the relationship between pressure and volume, volume and temperature, pressure and temperature, and I can identify the diffusion rate of gases. So do now. So there are some factors that affect pressure. The amount of gas, or the number of moles. If I increase the amount, this will increase the pressure, and if I decrease the amount, this will decrease pressure. The temperature: if I increase temperature, this will increase the pressure, and if I decrease temperature, this will decrease the pressure. And the volume: if I decrease volume, will um, if I decrease volume, this will increase the pressure, and if I increase the volume, this will decrease pressure. So Avogadro's law states, so this is an important law. It's always difficult to understand. But this means if I have equal volumes of different gases at the same temperature and pressure, then this means I will have the equal numbers of particles. So it sounds very confusing, but it's really simple. If I have the same volume of something at the same temperature and the same pressure, that means they have the same number of particles in them. So, for example, if I have 5 liters of neon gas at STP, this has the same number of molecules of 5 liters of xenon gas at STP because I'm at the same temperature and the same pressure. That's our STP. And they have the same volume. They're both at 5 liters. Therefore, they have the same number of particles. And that's Avogadro's law. That's what he said. That's what he said. Okay, so stop and think. See if you understand this idea. Okay, I'll go over this in class, and then stop and think. And I'll go over that in class. Okay, the pressure versus the volume. So this is Boyle's law. You don't need to remember their names, but you do have to know their relationships. Sometimes it helps remember the names if that helps you. Um, you can do that if you want. So as what Boyle said is, as pressure on a gas increases, the volume of the gas decreases. So this is the only inverse relationship. So you can think about it in this way. If I were to squish it down, I'm increasing the pressure. What happens to the size of my container? It gets smaller. So that means as I increase pressure, my volume decreases. So stop and think. Okay. Charles' law talks about the relationship between volume and temperature. So when temperature of a gas increases, volume increases at a constant pressure. So what this is now saying, I'm at a constant pressure. So I'm going to keep the same pressure, but if I increase my temperature, then my volume is going to increase directly. So stop and think, what happens to a car tire in the winter? Okay, and the final gas law is Guy-Lussac's law. And he said that when temperature of a gas increases, pressure increases when I'm at a constant volume. So this is also a direct relationship. So if I increase the temperature, my pressure is going to go up because as those particles start moving faster, they're going to hit the sides of the container more frequently and more and heavier. So sum it up. Here's a quick way to remember it. When temperature is involved, the relationship is direct. When temperature is constant, so it's not involved, it is inverse. And that sums up those 3 different gas laws. So stop and think, how does a pressure cooker work? This last law is the Graham's law of diffusion. So this is an important thing to remember. It's also quite straightforward but easily forgotten. Gases move from high to low concentrations, just like we know about osmosis and diffusion. However, lighter gases will diffuse faster. Lighter gases will diffuse faster. So if I have 2 different noble gases, neon versus argon, neon is going to diffuse faster because it's smaller. So stop and think. And check your understanding. All right, you can now determine the number of particles of a substance using Avogadro's law. You can determine the relationship between pressure and volume, between volume and temperature, and between pressure and temperature, and you can identify the diffusion rate of different gases.